Yes, I am Antti-Jussi Tiitola and I am from Kangasala, Finland. I was born in Tampere, which is the so-called ice hockey capital in Finland. And when I was a youngster, the ice hockey was very close to my family because my father already was playing ice hockey beginning 1932. And he was founder of the famous hockey team Ilves in Tampere. So in the junior ages I used to play hockey, but later I was involved in skiing and because team sport was not my best career, so I somehow finished in alpine skiing, and in 1962 I was in the Finnish national team in World Cup races and in alpine ski world championships. And after that, after that season, when coming back to Finland, I started to really think to how to manufacture skis in the modern way. My background is as an engineer is the university degree in material sciences in the University of Helsinki, the Technical University of Helsinki. And material sciences that time was mainly metal and metal physics. But because modern materials like plastics and fiber composites were unknown, so I became interested about those and made some studies about the performance of those materials. And finally I came to a situation where I had to build my first own ski, and that happened in 1963 in my own garage. Because that was the first so-called fiberglass ski in the world, it became created interest by some industrial entrepreneur, and I was able to finance the first ski manufacturing process in Finland in modern way. At the same time I have been thinking all the time how to make hockey sticks basically in the same process and same technology, because the knowledge about materials proved me that the fiber composite material could give a much better performance for hockey stick also, as it made for skis. And that's how I came to a solution where I designed the first sandwiched fiberglass hockey stick in 1966 and became my first patent in the hockey industry. Really in 1966 we started our own enterprise. My family, my father and other friends around him helped me in financing it, and we started to manufacture alpine skis first. But at the same time, in the cellar layer of elevation of that factory, I created a small hockey stick factory, and the name of the alpine ski was Titan, and it was very natural that also the hockey stick was named Titan. So that happened in 1966, beginning of December. And my thinking was that I could sell hockey sticks by motivating hockey players with my engineering skills. But it did not happen like that, because hockey players are not engineers. And when I offered them a very engineered design and asked them to use it, they said, "Why don't you make your stick with the shaft like the Canadians do. And that was the first answer. But luckily, because I had a good connection with the Ilves team in Tampere, some of the Ilves players started to play with the Titan stick, and slowly the stick became known about its excellent strength and durability. And the durability was the first real advantage what Titan was offering for the hockey players. And then later I developed the blade further by having a full length of plastic, so-called plastic rail in the bottom of the blade, which was against the ice, and it helped even better the stick to stand longer. And even on the street playing, many of the boys were still playing on the streets and backyards, and Titan was superior for that. It took 2-3 years, and Titan was a small brand, a few 10,000-15,000 sticks a year. But then later, some good happenings helped us to became more international famous. My knowledge is based on my engineering background, because I had a good know-how about composite materials. I have a good know-how how to construct flexible and strong constructions. So I can say that Titan stick was the first engineered hockey stick. Until that, all the hockey stick manufacturers were carpenters, and they based their knowledge on feelings and their skills in handling wood. But my stick was engineered. And that was also my weakness in the beginning, but later it became the strength. That is a very long story. But first we had to be able to come to the North America market. And that happened also through my skis, because I was selling my skis in Canada, and my agent for the Titan skis was a eager hockey man also, and when he know my Titan hockey stick, he wanted to sell them in Canada also, but it was not easy. But finally, when the Russian Soviet Union team first time played against NHL in North America, we had a chance to get the Russian players to use Titans. We painted the sticks red, and red Titan in the hands of superior hockey players from Soviet Union. It broke the ice for Titan sticks in Canada and USA. Later, when the stick volumes, sold volumes increased, we decided to build a stick factory in Cowansville, Quebec. And it was built in 1979, 1980. And when the factory was ready, we were ready to manufacture big quantities of sticks. And at the same time, our salesman, Robert Leader, came to us and presented us the young hockey player Wayne Gretzky. Gretzky was 18 years old that time, and Gretzky had tested Titan because he was a friend of Bob Leader, and he was ready to sign with us if we make him a special stick what he wanted. And we made it, and after that Gretzky was playing 11 seasons with Titan, and that helped us to become the world #1 stick in a couple of years. Same time we had the factory there, which was able to produce 1 million sticks a year. We had a factory in Finland producing 500,000 sticks a year, and in very fast time Titan was one of the most selling hockey stick in the world market. I don't know exactly what was the deal. When in that discussion where I was shaking hands with him, we only promised to make him his own pattern. And later I have heard that Titan North America paid him $1 a year until many years later when we lost Gretzky and the money was much bigger that time.
Yeah, somebody made a bigger offer.
Yeah. Oh yeah. He was one of the easiest pro player. There were many other who always wanted some small changes, etc. Gretzky, when we made one pattern for him, after that was always the same. He was good enough.
It's true, right?
Yeah.
That's awesome.
I really don't know exactly what happened on the floor, but I had a feeling that when he designed his blade pattern, after that he was satisfied and very happy what he received, and the feedback from him was mainly positive. He liked the stick. That time when the blades were pressed in the gluing press and then shaped afterwards, most of the players wanted to have some small changes, and the factory we had more than 500 different patterns offering, because even in the Finnish league players, they all wanted to have their own patterns, different changes. Today it's different because to make a mold, it cost a lot of money, and nobody can give that service anymore. I think the real reason why Titan became successful was the durability and the strength. And when Gretzky and other pro players started to use that made the name famous, but the real the image what Titan had was that it was the strongest stick on the market, and it came from our patented blade construction, not from the shaft so much, because shafts were strong enough anyway, but the blade construction where we had this plastic frame around the whole blade, and then the laminated composite layers on the both sides. And when these contact the ice, it always has the strong material against the ice, and it never wears off. And that is the real fact why Titan became famous, and because it was long-lasting stick, the first long-lasting stick on the market. There was a time when the two-piece stick existed, and that was in 19 1990s and beginning of 2000, when blades were manufactured separately and shafts were manufactured separately. And that came from the hollow aluminium shafts, where they assembled the blade inside the shaft, and that's how the two-piece stick was created. And first composite sticks, also commercial composite sticks, had the same construction. Blade was conventional and shaft was hollow composite or aluminium. But that type of construction is never good, because it has a very weak point where the blade and shaft is connected. It's kind of discontinuous point in the whole construction, because here is different of other material than in the blade, and there is a joint in the most critical part of the stick. And now if we think about PAMA's two-piece stick, that's a complete different story. The first thing is the shaft. And what is the purpose of the shaft? It is to flex so that you can absorb the energy of the puck into the shaft and then release it. But at the same time, the shaft has to be torsionally maximum rigid, so that when it bends, it does not twist. And that gives the direction stability for the puck. It always goes to that address where it was made. Second is that your blade has to be as light as possible, but at the same time as stiff as possible, because the light blade makes the stick very quick in handling, and the rigid blade makes again the directional stability, so that when you hit the puck, the blade does not give, and it addresses the puck's direction to the where the players want to have it. If the blade is too soft or shaft does not have enough torsional stability, the puck does not go to that direction what the player is thinking. There are two complete different parts, shaft and blade. They both have to be right designed and right engineered. I would say that all that practical experience together with my engineering skills has been used to design the PAMA, which has I call PAMA project as the ultimate hockey stick project, because in that project I have been able to realize all the engineering skills what I have and experience to one piece which I call hockey stick. Yes, that's no problem. It's more a question about the manufacturing process. And I would like to say that PAMA is already a one-piece stick, in spite the blade and shaft are manufactured separately. But it is a one-piece stick because it has the joint between the blade and the shaft in the right place, where it has to be. Yeah. And if we call this one-piece stick, it also has, you can even see that it has the blade and it has the shaft. And they are laminated together with the glass fiber which goes over this area. And it is a one piece. But in PAMA, what is in this PAMA construction, we have the same, exactly the same construction as here, but we made the blade hollow so that we can separate the blade manufacturing and the shaft manufacturing and join them together in as close to the player as possible, so that we can play with the different blades and different shafts. So this is the same thing. The construction what we have in PAMA is exactly the same what we have had in Titan, but it's made separately. Two advantages, or three. First is that when you produce the shaft, there is a different process to produce shaft than to produce blade, and we don't need to handle the shafts at the same time when we are building the blade. We can build only the blade separate, and that makes it much more practical in process. Second advantage is that with this construction we can make the lightest possible blade. And as I said, the light blade is very important for the part of this. A third is economical. We have, because we have many different flexes in shafts, many different fashions in blades, we don't need to connect them before we know what the customer wants. First, after the customer we know that customer want to have a flexible shaft and right blade with this pattern, then we connect them and send to him. And that's how we can save a lot of inventory in the factory. Instead of having 50 different fashions in the warehouse, if we have 10 different blades and 5 different flexes in the shafts, we have 50 different products in the warehouse. But now in PAMA we have only 15 different products, and of these 15 we can build all these 50 different options for the player. Yeah, one very important advantage naturally is that if you break the blade, or if the blade wears off, like in some stages, it's very easy to replace the blade, and we are also offering the service replacing the blades for with a decent amount of money, instead of throwing the stick away when the blade is worn off. Joint area where the carbon fibers are going around this hollow, how do you call it, hollow joint. We have the strongest part of the stick. It never breaks here. If stick breaks, it breaks over here or in the blade, but it never breaks in the joint area because of the construction. I went skiing with my wife and the dogs, and after that swimming in the lake. Cold?
Cold?
No.
No?
No.
It would be for me.
After that I was designing new machinery. Not this time not for the hockey industry, it was for our ski manufacturing process. During the lifetime of my patents, more than 15 million sticks were sold, that I know. And my former production manager when I told about 15 million, he said, I think it was bigger because my best day I was producing 5,406 a day. When the business was on the best stage. So anyway, quite a few millions. First of all, it's a question of how much the consumer is ready to pay for a good product. But really, the cost to manufacture a composite stick, it's higher than the cost to manufacture a conventional fiberglass stick, etc., or same, because it's very difficult to fully automate that. And if you think how the competitors are producing their sticks in Mexico and in China, they are mainly made in hand operations, wrapped with the hands, and they need a lot of different operations there. And it's a cost of manufacturing. First material, second labor cost, and third the cost of in a big brand, it's a cost of marketing also. First is that PAMA has this patented joint. This is unique for the whole industry. Second is that PAMA is at the moment the only stick what is manufactured in Europe. All the other sticks are manufactured either in China or Taiwan or Mexico, in the low labor countries. And third is that because we are manufactured in Finland, we are able to give a very flexible service for the customers, for the hockey players, much faster than anybody who are manufacturing big factories in far away countries. I know from sporting goods dealers who are suffering over the fact that they have to place today, now in April, the orders for next September, to be able to receive their sticks in September. And that's almost impossible situation if you at the same time would like to give a good service for the players. A lot of sticks are breaking, and that means a lot of carbon fiber waste is hanging around the hockey rinks, if you think that there will be sold about 5 million hockey sticks in a year all around, almost half of that 5 million sticks are breaking during the season, and they are somewhere as scrap. So that's a big problem that concerns me, and I hope the future can offer some kind of materials which are better for environment than the broken carbon sticks are. It comes from that before I had clothes, I was naked, but I have a new way for my nickname, NAKU. What does it mean? Not any kind of uniform. And that's my name. I am not uniformed. I go my own ways. Really here we have my first stick even before the Titan name was invented, and that patent application is made in 1966, and that patent included the sandwich construction where the glass fiber was going all the way from shaft to the blade on both sides of the wooden core. And that stick was covered with the wood surface because all the hockey players that time wanted to have a wooden feeling in their hands. And they even asked me, why cannot you make a stick with a ash shaft like all the Canadians do? And really this was the world's first glass fiber stick where I used a similar sandwich construction as I used in my Titan skis. Later I developed this blade which has we called it plastic framing around the blade, and it was even at that time in the blade core we had to put some piece of wood there because the players wanted to have the wood there because of the feeling, and then we covered the both surfaces with fiber, and also the touch surface was covered with wood in that time to get the feeling. That's very much mental thing in that. But because of that plastic framing in the blade, what also was patented for Titan, because of that framing, the stick was the absolute most durable stick on the market at the same time, and because of the durability, Titan finally became successful. Not only because of the good professional players, but also because of the durability. The normal people wanted to have Titan sticks. Yeah. The basic idea in the PAMA stick is that we produce shaft in the continuous process where the shaft fibers are wound around the shaft core, and we have a continuous fibers from end to end in the shaft. And second, we have a process to produce blades, and the blade and shaft are joined together in this, we call it ankle area, where the forces are the lowest. It's a big force in the blade when the puck hits. It's a big force in the shaft when it bends. But in this area, the forces are in minimum. They even go from plus to minus in that corner, and that's why this is the only and right place to join the shaft and blade together. I think the most important thing that everyone finds their own feeling for the sticks, and because now with the PAMA concept we can adapt the stick better to the player's own characteristic and performance, and that's how every kid can become a better hockey player by using PAMAs. So in PAMAs, because we are manufacturing in the country where the labor cost is high, so we cannot make any cheap sticks. That's why we have concentrated to make all our models in a professional level. They have differences in their performances adapted to the different players, but all the sticks are professional level sticks. Some of them are thought for the forward, some of them are thought for the defense players, but you can over two different shafts and couple of different blades, you can always combine your own stick for your own special needs.